Good afternoon, everyone. I'm George Muniz, founder and CEO of Ascender Systems. We're here to present SENTRY, a new approach to tactical bridge health monitoring, delivering persistent intelligence before, during, and after Army mobility operations. Today's Army bridge health monitoring faces a significant gap. First, manual inspections are delayed, episodic, and unable to support real-time decisions. Next, there is no persistent lifecycle monitoring, especially during storage or post-damage conditions. Third, vehicle loads are not tracked or correlated with bridge health, making fatigue and readiness assessments unreliable. And finally, corrosion, a leading cause of degradation, lacks automated continuous sensing, increasing risks to our mobility forces. Our solution is SENTRY, the sensor-enabled node for tactical readiness and yield. It is a modular, off-bridge architecture designed to deliver persistent tactical intelligence. The system consists of two elements, a robotic climber and an elevated SENTRY node that is two-person installable and packaged as shown on the bottom. The climber is manually installed at a nearby pole or vertical structure, elevating the SENTRY node quickly without deck access. Once fully deployed, the SENTRY node acts as an intelligence hub, receiving wireless data from the bridge below. And it fuses and correlates that data with the electro-optical and infrared imagery and vehicle direction and tracking. The system performs real-time AI data processing. It then stores the data locally on its SQL server, or it exfiltrates via a secure tactical scalable MANE. On-bridge sensors, as shown in blue, shall capture strain, displacement, acceleration, and vibration and wirelessly transmit their data through a centralized gateway hub to our off-bridge SENTRY node, shown in green. EOIR sensors on the node also perform vehicle classification, direction tracking, and corrosion monitoring. All of this data is processed on board and stored locally. It is then exfilled securely via tactical C2 systems with full WinTAC, ATAC integration. SENTRY is deployed once during bridge emplacement with no need for repeated deck access. Its elevated position improves survivability and, as shown on the right, greatly extends the RF line of sight to over 7 miles on a single hop. This enables longer range connectivity and to the battlefield commanders, and it also enables continuous monitoring even during extended operations in a denied environment. The system is built for tactical integration, giving engineers and commanders real-time lifecycle intelligence without adding operational burden. SENTRY outperforms both legacy tools and many emerging solutions in key mission areas. It is the only system that separates remote sensing from the deck, enhancing survivability and rapid deployment. For example, in the event of an IED attack, SENTRY would continue monitoring events and providing threat assessments to the commander. It fuses strain, vibration, and visual data in real time, delivering a full operational picture, and it is fully secure and Win-ATAC compatible, built for Army tactical use. Across our competitors, most solutions remain deck-mounted, episodic, or lack tactical integration. SENTRY stands out as the only elevated, persistent edge AI solution that specifically does not require any human interaction once installed, making it designed from the start to meet the Army's operational intent. SENTRY supports multiple bridges across their full life cycle. It provides go-no-go intelligence even in denied environments, supporting critical mobility decisions. It replaces manual PCMS and crack coupons with persistent automated data, and it enables readiness-based sustainment, reducing risk and avoiding unnecessary replacements. In Phase 1, pre-mission, SENTRY deploys with the bridging team. Phase 2, combat crossing, it fuses strain and vehicle data in real time. Phase 3, storage mode. It continues monitoring during storage or staging, detecting degradation early using a compact 120-volt AC SENTRY mini module maintained in the warehouse. And finally, for post-blast, it enables rapid damage assessment and clearance calls. Our system is built on validated components with a clear path to Army fielding. The Robotic Climber and SENTRY node are patented and field tested on multiple vertical structures. On-bridge sensing leverages Resense's strain and vibration sensors, proven in Department of Transportation and DoD projects. The node integrates trellis-aware tactical scalable MANET radio and EOIR sensors in real-time edge fusion and with Win ATAC compatibility. All components are MIL standard compliant or field hardened, designed for our austere Army environment. This is a TRL 6 Plus architecture, ready for Phase 2 validation. We've conducted structured risk assessments grounded in Army operational reality. Key risks include sensor degradation, exfil disruption, and deployment errors. We mitigate sensor risk through fault detection and replaceable sensor head. Exfil disruption is mitigated through store and forward buffering and burst-based relay, supporting low signature operations as well as alternate waveform use. Deployment risk, including failed climber attachment, are addressed through quality assurance processes and installation checklists. On the opportunity side, we are leveraging proven sensor and commercial off-the-shelf component systems, thereby reducing integration time. We propose accessing SENTRY SQL data via standard ATAC WinTAC plugins, thus supporting immediate Army ConOp use. And if off-bridge deployment is adopted as an Army standard, it directly reduces lifecycle and sustainment cost. Bottom line, this is a low-risk, high-reward architecture aligned to the Army's transition needs. Our Army transition pathway is designed to move SENTRY from a validated architecture to a fielded Army capability. In Phase 1, shown in blue, we're proposing to target transition through PdM Bridging, Mr. Chris Upton, with strong engagement from GVSC and the Bridge Tech Lab. By mid-Phase 2, shown in yellow, we'll execute our demo at Fort Leonard Wood or Proving Grounds, supporting bridging modernization goals. Because our system is built on modern open system architecture principles, we can ensure program of record compatibility, thereby supporting rapid acquisition. We're structured for cooperative R&D agreements or OTA transition, enabling accelerated Army handoff at Phase 2 conclusion. As shown here, we have a clear and executable transition plan, moving from TRL validation, stakeholder engagement, and an Army fielding pathway. Dual use and commercial applications. Beyond the Army bridging operations, SENTRY applies to critical civilian and interagency missions. It was designed first for combat bridge monitoring, but it can be readily adapted for Department of Transportation, bridge inspection, FEMA post-disaster, utility infrastructure protection. The same rugged AI ruggedization and secure wireless backbone supports scalability applications across all sectors. And more importantly, dual use helps reduce Army lifecycle costs, delivering value back over to the Army. We've built meaningful traction, de-risking Army transition and supporting Phase 1 and Phase 2 execution. We have legitimate traction across technical development, commercial engagements, and multi-use defense opportunities. Technically, both the Robotic Climber and the SENTRY nodes have capabilities and potentials that have been successfully demonstrated. Strategically, we're progressing through both xTechIgnite and xTechOverwatch, while actively engaging with FEMA, Sector 9, local Department of Transportation, and state agencies on targeted use cases. Commercially, we have active demand from Department of Energy, FEMA, San Diego Gas and Electric, and others to help reduce Army transition costs. Finally, we've secured over $250,000 in non-diluted funding across federal, state, and private sources to include organizations such as the California Office of Small Business Administration, Veterans Business Battle, and the Semperfi and America Fund, all of which have been used to directly support Climber and SENTRY development. This demonstrates both early market validation and financial maturity. Our roadmap moves SENTRY from a validated architecture to a fielded Army capability. Our primary path is through defense and government transition, but by late 26, early 27, we'll have executed our Phase 2 field demo with GVSC and Fort Leonard Wood, have engaged with PdM Bridging, and will be targeting TRL 7 or 8 validation and dual-use transition opportunities. Simultaneously to our efforts supporting bridge health monitoring, Ascender Systems will also seek to leverage the Robotic Climber for elevated installation of both a passive drone detection capability and an automated multimodal sensor suite. Meanwhile, we have also been pursuing targeted FEMA and Department of Homeland Security for post-disaster bridge triage and infrastructure recovery. Parallel B2B and B2C pathways help support cost sharing and dual use scaling, further reducing Army lifecycle costs. We've built a focus team with the capabilities required to deliver both Phase 1 and Phase 2 Army transitions. I lead Ascender Systems as founder, CEO, and systems architect with over 25 years in military aviation, robotics, sensing platforms, and 10 years in government contracting. I've led the development of advanced sensing systems and ruggedized ISR for the Army and joint operational environments. Dr. Molchanov, our RF and EO communication systems architect, brings over 2 decades of experience in low radar cross-section detection, multimodal sensing, and ruggedized photonics design, with direct contributions to Navy and Air Force and Army programs. Irina, our AI, ML, and computer vision lead, is an expert in EO/IR fusion, anomaly detection, and neuromorphic edge processing, enables SENTRY to intelligently correlate vehicle type, bridge fatigue sensors, and corrosion projection. Jacob leads our mechanical engineering for the Robotic Climber and SENTRY node with a focus on field-reliable, rapidly deployable system. Luke has embedded sensor integration, delivering mission-ready edge processing and MIL standard hardening for electronics for SENTRY suite. We also leverage a pipeline of engineers and interns from academic partnerships supporting scalable program growth. This is a ready-to-execute team capable of delivering a successful Phase 1 and Phase 2. In closing, here's why Ascender Systems is the right team, why it is the right time. Our architecture delivers persistent tactical intelligence through off-bridge sensing that enhances survivability and mission readiness. It aligns with MOSA principles and Army ConOps and is designed for low lifecycle costs and easy sustainment. SENTRY is mission ready for Phase 1 and subsequent Phase 2 field trials. We bring validated dual-use traction, reducing transition costs and risks. Our Army communication networks are all field tested and proven. Our path is clear: GVSC, Fort Leonard Wood demos, engagement with PdM Bridging, and preparing for Army fielding. Dual-use scaling supports Army cost reduction and accelerates our transition. Bottom line, this is a low-cost, high-reward solution, ready to deliver persistent bridge health intelligence for Army mobility forces. Thank you, and we look forward to your questions.